All right, today we're going to solve system equations looks like this. The problems that are going to be coming up in the near future that look like this are called uniform motion problems. It would say something like this. Paul drove for 50 miles an hour and then Anna drove at some speed. Yeah, Anna drove at some speed. Paul drove for 4 hours, Anna drove for 3 hours. After however long, they were 320 miles apart. That's kind of the problems that's going to happen. I don't actually do the problems this way when we get to those problems, but that's what we're getting up to. I just like to deal with these problems because it gives you a good look at substitution that we've already dealt with, but on a bigger problem scale. And what I want you to notice on these problems is that there's four equations, four variables. R sub A and R sub P represent two different R values. T sub A and T sub P represent two different time or T values. And again, it's the purpose of these problems here is a rate time distance problem. So rate of Anna, time of Anna, rate of Paul, time of Paul. Okay, and that's what that's talking about. But the top equation, you'll notice, has every single variable in it. All four variables happen in this top equation. For the sake of calling it something, I'm going to call it the main equation. The equation containing all the variables is going to be the main equation. The other three variables, the other three equations are substituting equations. And a good substituting equation has this specific characteristic. One of the variables in the problem equals something else. In this case, they all equal numbers, which is great. That's the easiest kind. But if it said T sub A is equal to rhinoceros, that's more useful than T sub A. All right, it doesn't matter what they equal as long as they equal something else. So R sub P is equal to something else, T sub P is equal to something else, T sub A is equal to something else. All right? So what we want to do for our first step in this problem after we've identified the main equation and substituting equations is substitute everything in all at once. All objects that can be substituted get substituted. Nothing down here says R sub A is equal to anything, right? So R sub A is going to stay R sub A. That's being multiplied by T sub A, which equals 3. That's being added to R sub P, which is 50, which is being multiplied by T sub P, which is 4, which equals 320. So each of these three guys, T sub A, R sub P, and T sub P, got replaced with what they equal based on these facts down here. The structure of the problem stayed the same. Multiplication of two things added to the multiplication of two other things equals 320. After we substitute all that stuff in, notice that the only variable left over is this. So if I go to solve for that variable, 3R sub A plus 200 is equal to 320. Subtract 200, that gets me 3R sub A is equal to 120. We divide by 3, we get R sub A is equal to 40.
On 9 it says R sub A is equal to, wait.
Are you in the back? Just to the front? There you go. All right.
Okay.
So now you're on the same
Now
problem?
I gotta write everything down again.
That's fine. All right. But R sub A is equal to 40. And notice it says to solve this, right, for R sub A. Sometimes it just says solve. Anytime it says solve, it means find everything you don't know. Of the four variables here, the only one I don't know is R sub A. Everything else is known because they tell us specifically. Sometimes you don't know one thing, sometimes you don't know two things. You won't be beyond that point in this class. Or at least not, if we do, it'll be right towards the end. In Algebra 2, we do these where you don't know any of them. Those are a little bit more challenging, but the ones we're going to get here are going to be pretty much like this.